Well, I've had several requests, and some of them are actually anatomically possible, believe it or not. But that aside, someone said to me, "Go on, Steve, do a little bit more on this latest offering from Ben, the Apollo Defectives." I said it's painful stuff, it's difficult to watch, it's all absolute drivel. They said, "Oh, please, go on, just please." I said, I'll have a look, okay? I'll have a look, and I'll do a little bit more on this bloody nonsense. So here's part 2 of the Apollo Defectives. Now, I think what we'll start with is the chef and a couple of his pictures. Now, he shows a picture of a... actually, I'll show you the pictures. What I'll probably do is have a quick look on the video and then go to the actual NASA photographs, rather than go to his Orlis site, because he might start screaming copyright, you know. And the other thing too with the Orlis site, don't go there, please don't go there. That site would insult the intelligence of a cheese and pickle sandwich. Just don't bother with it. So what we'll do, we'll just start with this guy and a couple of images. He's talking about the lunar rover having an oil leak on the back wheel. And he's also talking about this plate that's covered in mould. Covered in mould. And he's got no idea at all. He thinks, of course, that he's on the ball. So much, though, that let's just listen to this. I think this is quite funny. Hang on. I need to take some bass out of the speakers. I'm still not using screen capture, and sometimes I forget to take the bass out of the PC audio system, and it's difficult to hear what the people are saying. Probably wouldn't be too hard to hear this particular guy, though, because he sounds like he's a refugee from a cartoon. He's in the right place, though, isn't he, really? When you come to think about it. Okay, right, now let's just see if this is anywhere near the right place.
And kind of where you're coming from, out of interest.
I'm a chef by trade, and I'm as sharp as my knives.
This is the guy that's talking about the oil leak and the cars being used on the movie set, and the plate covered in mould. He's a chef by trade, and he's as sharp as his knives. Now, personally, I think he's probably not quite as sharp as a billiard ball. But we'll see what he's got to say about some images, and you can make your own mind up as to how sharp you think this particular chap is. Okay, well, let's go on to the clip of the metal plate covered in mould. Right, now I've just started this just a little early, but let's just see what he's got to say about the plate with the mould on it.
That is very wonky.
It is like it's been dropped.
Not quite as wonky as the analysis that's going on here, but I might look at this one a little bit later. I don't know. It's just rubbish, of course. Okay, let's just.
With another module. This is how it was prepared. This is the experimental package, right? The experiments are on the top. Mm-hmm. This thing is supposed to convert in and power everything, and that's all they did is a frame. You can see there's mold all over it. This is just an old piece of equipment that they were practicing with here on Earth. And
there's mold all over it. This is just an old piece of equipment they were practicing with on Earth. This is supposed to power all the surface experiments, the lunar experiments. Well, there is some truth in this, believe it or not. This is actually the base plate for the little radiothermic generator. It's a SNAP 27 is the model, which is a Systems Nuclear Auxiliary Power System, SNAP, model number 27, so you can Google it and find out all you need to find out about it. This is the base plate for it. And he's saying this is an old piece of junk basically, and it's covered in mould. It's covered in mould. I thought, really, we'll have a look at the original NASA image. And of course, what these people don't do is this is one in a sequence of images. They don't show you the image before, because if they showed you the image before, it would completely explain the appearance of this plate. Now, I don't know if that's poor research, because he's saying the other video he was saying the Omega watch is $25,000, and he was saying that the Orion's powered by a ZX81 or something. Anyway, what we're going to do is we're going to look at this image, the original NASA image from the NASA website, and we're going to look at the previous image. Okay. And we'll get quite a convincing explanation, I think, as to why this looks as it does. Okay, here we are on the NASA website. So we go up here, NASA, and it's telling us that it's AS12 46 67 91. Okay, that's the image number. AS means it's Apollo 12, and that's Alan Bean struggling with that white painted broom handle. I'm surprised I haven't pitched that one in. Now remember that this is the surface experiment package they're putting together, and this is just a way of carrying the base plate over to where they're going to plant it and set it up, basically. So this is a carry bar that they're putting in here, and this is the base plate for the radiothermic generator, the RTG. Okay, so as I said, this is image AS46 67 91. So let's go to AS12 46 67 90 and see what that image shows us. I'll do that while I'm without stopping the camera. Can I? What one do we want? 89. So I want this one, 67 90. Right. Okay, so here's the previous image, because remember it's a sequence of images. This is AS12 46 67 90. So this is, remember the other one was 67 91. This is the previous image. Now what this is an image of is Alan Bean, and he's putting the radiothermic generator together. So what he's actually doing here is taking the cartridge of plutonium-238 out of the canister, and he's going to insert it in here. And it's plutonium. This cartridge of plutonium-238 is generating 1,250 watts worth of heat. When he plugs it into there, there's a lot of thermocouples in here. They're going to start generating electricity. There's veins around here to keep them cool them down, or keep them at a temperature that's going to keep them happy. So 70 watts of electricity out for 1,250 watts of heat in. So very, very inefficient devices, radiothermic generators, but they do produce power for a long time. Voyager 1 has a both of the Voyagers actually have got radiothermic generators, and they're both still producing power, and they're still producing radio signals that are being received today. That'll be a good one for the chef to explain his inverse square law. He's heard this term, inverse square law, and he's wrong with it, but he's got no idea what it means. But we'll be looking into that a little later. Anyway, so this is Alan Bean. Sooner him than me, pulling a cartridge of plutonium-238 out of this canister, and he's going to drop it into this cylinder here. And we can see, if we look at this image, this is the base plate of the radiothermic generator that we were just looking at, and we can see that while he's walking around and he's manipulating this thing, he's kicked some lunar dust over the plate. That's what's happened here. See the lunar dust? He's kicked the lunar dust over the plate. And what do we know about lunar dust? Well, we know, contrary to what you may hear in this presentation by Ben, the Apollo Detectives. Lunar dust is not radioactive, but because it is constantly bathed in cosmic rays and solar wind, the lunar dust does have a slight electrical charge, which means that it adheres to surfaces. So he's walking around, he's kicked up a bit of dust here, it's gone on the surface there. As he pulls this plate up through the vertical, a lot of it's going to just fall back to the surface, and there'll be a remainder that will be adhered to the plate. So that's it's not mould. Who would have picked that? It's not mould at all. So this was a shiny new plate. He's put it on the ground, he's put this thing on top of it, he's walking around, he's putting this thing together, remember, he's assembling it, and he's kicked some lunar dust over it. The lunar dust has adhered to the plate. So, no mould, I'm afraid. So I think we can kick that into touch. Alan Bean, Apollo 12, assembling the Snap 27 RTG, the system's nuclear auxiliary power unit, model number 27, radiothermic generator, 70 watts of electrical power, 1250 watts of heat. Okay, well let's see what else we can find. Now what the guy with the red nose and the large shoes is saying here is, oh sorry, this is another NASA photograph. This is from the NASA website. NASA. This one is one of the pictures he quotes on his site. He puts this number 88 1190 11901 against two pictures, and what he does is he sort of blows this bit up and he blows this bit up and says these are both from this image. So this is the image he references on his website. Again, don't waste your time. Now, the oil leak that he describes is always on a rear wheel. It's never on a front wheel, it's always on a rear wheel. Never on a front wheel, always on a rear wheel. And that's because as the rover goes along, the dust is kicked up from the front wheel. Of course, there's nothing in front of the front wheel to kick the dust up, so the dust will stick to the hub. But the dust kicks up from the front wheel, and because there's an electrical charge on it, it tends to stick to stuff. It sticks to the rear wheel, and it sticks to the rear wheel, sticks to the rear wheel hub. That's what's going on there. It's just his complete misinterpretation of what he's looking at. I mean, do you see any streaks anywhere? Any oil streaks? Any streaks across the hub here? You can make this. Can I make this really big? I don't know actually. But anyway, let's have a. There are no streaks coming out. Because it's centrifugal force. The wheel's going to be rotating. The oil streaks will be coming out here. They'll be running across the. This isn't a tyre, remember, this is a mesh type arrangement, but there'll be patches of it here. Certainly where it's parked it would be sort of running down, because remember there is gravity on the moon, albeit 1/6, but it's still going to stick in the car to the moon, so it's going to pull the oil down to the lunar surface. So there is no oil leak. This is just a very good example of how poor this guy is at photographic analysis. And all the other guys, of course, they lap this up. They sit around. Oh yeah. I'll show some examples of this a little bit further on in the video, where some absolute rubbish is, ridiculous comments are made, and the people, they lap it up. They just can't get enough of it, and they just. I don't know why Marcus Allen is still appears to be lapping this up, because we know from his Freudian slips that he knows very well they went to the moon. But they're all, oh yes, okay, oh yeah, of course, ah, ha 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 ha, And the comment that was made is almost too ludicrous for words. It's almost too ludicrous for me to even bother commenting on it. But anyway, I thought I'd just show you just a couple of things from the guy with the peculiar voice, the chef. That's as sharp as a billiard ball, well, very nearly. Before we move on to the others, before we move on to comments from the others. And some of them are quite funny. I'll tell you what, there was one. No, I'll tell you when I get to it. I'll tell you when I get to it. Okay, well, on to the next clip. Well, okay, as excruciating as this is, let's hear some more pearls of wisdom from Scott Henderson, the chef that's as sharp as a billiard ball.
Right there.
So a question. Let's say that the Chinese or the Japanese or the Indians independently send their own probes to the moon with high accuracy, high definition photography, and they photograph the moon landing site with all the objects, the moon, the rover, etc., all their bits of kit in place. What do we do with our position if that were to happen?
Well, first of all, they're not going to be able to send the images back. The inverse square law won't allow that.
Now, they're not going to answer the question, of course. They can't even bring themselves to say, well, you know, if that actually did happen, you know, one of these Chinese, the Japanese, or the Indians went to the moon and sent back high-definition pictures showing us all the Apollo stuff is there exactly as the Americans say it is. They wouldn't say, well, okay, fair enough, I was talking out of my backside. I was obviously wrong. They can't even bring themselves to say that. They have to find reasons why that would never happen. I'm beginning to think these people here are aspiring to be imbeciles. I really am. Now, Scott Henderson has heard the term inverse square law. He likes the sound of that, and Marcus Allen does too. Marcus Allen's used it a couple of times, but neither of them, of course, have any kind of grasp of what it actually means. Now, what I would like to say to, what I'd like to ask Scott Henderson is perhaps he could explain to us all out here in YouTube land, as part of enhancing his case, how exactly the inverse square law would prevent high definition pictures from the moon, yet allow pictures like this. This is from NASA site. This is not from the Beano or from Nexus magazine. How would the inverse square law allow pictures like this to come from Mars? And Mars is, I think, between 50 and 80 million miles away, depending on where it is in the orbit. The moon is only 250,000 miles away. Mr. Henderson is saying the inverse square law would prohibit getting pictures like this from the moon. Now, I suppose he's going to say, well, you know, it's huge. This is obviously Olympus Mons. In fact, what this is... Okay, it's a close-up image of a 2-inch deep hole produced using a new drilling technique for NASA's Curiosity rover. The hole is about 0.5 inches, 1.5 centimetres in diameter. The image was taken by Curiosity's mast camera, Mastcam on Sol 2057. So there you go. So this is a so it's 1.6 centimetres in diameter, this hole. So you can see the definition is really quite good, isn't it? It's 1.6 centimetres in diameter, and I think that's quite a detailed image, really, isn't it? When you come to think of it. So perhaps you could put that to him, Ben. Scott Henderson, ask him to explain for us exactly how the inverse square law would allow this picture from Mars, yet prohibit a very similar image from the moon, which of course is orders of magnitude closer. But I'll tell you what, if he says that he's going to give that a crack on your channel, could you give me advanced warning, at least a couple of days advanced warning, because I would need to go out and buy some rubber underpants for that one. For sure. Okay, this might be a fairly trifling thing, but it does show that that they pull figures out of the air. They don't do any research whatsoever. These guys. This is the same guy, remember, that was talking about the inverse square law. He was talking about the price of the moon watch. So let's just see what he has to say about the air pressure on Earth.
Doesn't have anything pushing down on top of it. On Earth, we have the Earth's atmosphere on top of that pushing down, which is 10 pounds per square meter.
Okay, so this is Scott Henderson again. He's saying we've got 10 pounds per square metre of air pushing down on us, on the Earth. All right, well, let's just have a look and see what the air pressure on the Earth is. Okay, so the air pressure on the Earth is actually 14.7 pounds per square inch, not 10 pounds per square metre. If I was going to cover every inaccuracy in this presentation, I'd be here forever. So I'm just going to pick a few things just as examples to show, you know, how ridiculous these guys really are. Okay, so that's just Scott Henderson again, more pearls of wisdom. 10 pounds per square metre of air pressure on the Earth. In fact, it's 14.7 pounds per square inch. Just Google it. Any number of sites will tell you the same information. All right, next. Okay, so I should let that run on actually, because they've got a scientist on board this time. And I was listening to this guy, and he introduced himself, and I thought, oh, okay, this guy might be worth listening to, and I was quickly came to the conclusion that he wasn't, and I thought, good grief, you know. After about 2 minutes of, if I spent a couple of minutes in a room with this guy, I would want to lower him feet first into a wood chipper. Feet first, because I wouldn't want the screaming to stop too soon. I want to savour every syllable of the screaming. Okay, now every second of the screaming. Pardon me, I've got a Diet Coke here. I'm not drinking a beer. Okay, now anyway, let's just have a quick listen to what this scientist. I think he said he did physics and all this sort of stuff. Let's just have a quick listen to what he says, and we'll do his introduction a little later, or it may be a bit before, because this is an individual clip. It could appear, you know, ahead of or behind maybe the other one. But anyway, let's see what he's got to say.
Moon doesn't have that. There's no wind. There's no rain.
Oh, I forgot to mention, of course, that Scott Henderson is also the guy that was talking about the mouldy dinner plate. Sorry, the mouldy metal plate, and the oil leak on the fake lunar rover. So, you know, he's not doing very well, is he, Mr. Henderson?
And there's nothing to push it off.
Can I use this as a point I wanted to bring up? Dust. That's another one.
Now, this is their scientist. Dust. He wants to talk about dust.
There was so much dust within the module. There was so much dust within the suits. And
now, there's so much dust within the module, so much dust within the suits. I think that's an interesting comment from a physicist. Well, we know the lunar dust's got a small electrical charge, tends to cling to things. It's going to cling to the outside of the suit. But perhaps, Ben, you could ask your scientist here to explain to us all exactly how the dust would get inside a pressurised spacesuit. That's quite... I would like to hear that. I really would. Okay, let's just let's run this on a bit. As I said before, previously, or later, this really is excruciating drivel.
that dust would have mopped up everything, because especially as I was saying before, they have lots of very sensitive material in there. Plus, you've got no gravity. That stuff's really bouncing around. And,
Well, yeah, in space, okay, there's no gravity, but certainly on the moon, they're not going to have any problems with it because there's 1/6 gravity on the moon, isn't there?
around inside your capsule.
Yeah.
It's not going to be floating around inside the capsule on the moon. And you would think that NASA might have considered this. You know, they're probably not going to have any gaps where dust can get into any of the systems. You know, people design this stuff. They don't just go down the shed, you know, with a hammer and nails and a rivet gun, a few sheets of aluminium and some oxygen bottles. You know, that's not how it works. It's all very carefully designed. And I'm sure they would have taken that into account.
But this dust has been falling on the moon for 3.8 billion years.
Yeah.
Right?
Right, okay. So is he going to complain now that it's not new dust?
So
How thick would it be? It has to be on top. Every shot you see with a bare rock, okay, is just an error in simulation.
Okay, well, I haven't looked to see what NASA have to say about that, but yeah, this dust is very fine, of course. Perhaps it's just the solar wind that keeps it off the rocks. Do we have any pictures of rocks that don't have dust on them? I wonder. Maybe most of the rocks do have a thin layer of dust. I might have a look at that one.
Mm-hmm.
Yeah, I've never thought about that.
Even
Really.
if you say it's only a few inches thick, it's got to be.
Well, everything.
More than that, it's filled in the craters on the moon. You can see it in the telescope. You can see a fresh crater impact, or a recent one has the radial striations coming out from it.
I mean,
The older ones are being filled in with this lunar dust, the cosmic dust coming down.
Well, I'd be interested to know how he would know how recent a crater on the moon is. Perhaps you could tell us that, Mr. Henderson. Of course, you're going to have stuff, you know, going out radially. Stuff will be ejected from the crater, from the impact point. But how would you be able to? Perhaps you can demonstrate to us a recent meteor impact crater that is being filled with dust. Yeah, I'd quite like to see that.
Onto it, or dust from other impact craters.
Colin's right. I mean, what happens if you have a dusty spacesuit and you bring it into a spacecraft with sensitive electrical equipment? That's
It's radioactive.
Yeah.
No, again, Scott Henderson jumping in feet first. It's not radioactive.
They jump out of their suits. They jump out of their suits in the spacecraft, and the radioactive dust is all over their bodies. And then
So they're jumping out of their suits like gazelles. They're jumping out of their suits. They're not sort of getting out of their suits carefully. Maybe leaving the suits hung up or on the floor somewhere. They're jumping out of their suits, so they're creating these clouds of radioactive dust that's floating around inside the capsule, inside the crew module.
they bring 2 kilos of radioactive rock on it, and they travel back from the moon for 3 days. Okay? The dust won't settle. They're in zero gravity. They're going to be breathing it in. It'll be in their eyes.
It won't settle, but it'll stick to surfaces, won't it? And probably stay stuck to the spacesuits, I would imagine.
It'll be in everything.
Perhaps they put the spacesuits in a bag, seal it all up. They get out of the spacesuits when they finish with them, and they put them in they put them in a bag, seal them up. And that would sort of make sense to me. And you would have no dust going anywhere, would you? Because the dust would be adhered to the suits. Seal the bag. Where's the dust?
Okay. Would somebody like Brian Cox be saying, aha, but they've of course got oxygen filters and air filters that would remove
But
the
they
dust?
didn't.
This is radioactive dust as well.
Well, there's the scientist, and he's jumping on board with the radioactive dust. If this guy really is a scientist, I would strongly suggest he goes back to the university that issued his degree and asks for a refund.
Oxygen filters, etc. Right. The whole point of radioactivity and dust, if that gets into your body in any shape or form,
Yeah, okay. All right. Well, we'll have one more thing on the radioactive the radioactive dust. I'll move that forward because again, this is rather excruciating. He's going to swear there. I do feel like swearing myself actually, but I won't. Okay. So let's go to 49, 349. Okay, let's just see what he's got to say here. I thought this was quite amusing.
Yeah, even around Chernobyl, they still wear masks, so they can't breathe it in, just anything that's blowing around.
Completely different sort of radiation, of course.
And we're talking microscopic. We're talking about, if you just get a couple of atoms of that stuff.
Now, he knows, he's been to the moon, of course, and has carried out careful analysis of lunar dust.
Yeah, this stuff is pretty lethal. It's pretty harsh because it's giving out one atom is giving out a very large amount of energy. So even if it's only one atom, it's going to destroy a lot
Remember, the dust is not radioactive. This is all nonsense.
of cells.
My brother actually went to Chernobyl and he took some old clothing which he bought and he did the whole tourist thing, went round there, and when he got back I think he burnt the whole lot or destroyed the whole lot.
I thought that was quite funny. So his brother went to Chernobyl and he burnt the clothing because he thought it might be radioactive. Now, it's funny, you don't hear of people collecting all the radioactive waste from Chernobyl and burning it, do you? It doesn't seem to have much effect on the radioactive material burning it, does it? If it was as easy as that, they would have set up some incinerators, a few 44-gallon cans around Chernobyl, poke some holes in them, of course, and put all the radioactive material into these 44-gallon drums and set light to it, and boom, there you go. No more radiation. You wouldn't have to worry about encasing the whole plant in concrete for the next 15,000 years. So perhaps this guy, I don't know what this guy's name is, this English guy. I've lived in Australia for too long. Actually, that's not true. I could never live in Australia for long enough. Whoever this English guy is, he's got absolutely no idea. So radioactive clothing, all you've got to do is burn it, no problem. Done. And pun intended, dusted. All right, well, let's see what else there is going on here. Okay, before we look at Marcus Allen's comments, let's just see what else the scientist has to say.
Because all you've got is a couple of pixels.
Yeah, and if they showed more than that, of course, they'd be saying, fake, they're fake, look at these, they're far too good to have really been taken from the lunar surface. You just can't, they just will not, they will never ever admit it. If you took them there and stood them in front of a descent stage that was still sitting on the moon, they'd say, you put that there yesterday, you know you did. These people are just I don't know. A question I'd be asking their scientist as well is, I'll ask Ben to ask the scientist if he's ever been under the care of a mental health professional. I think that would be an interesting question for him. Okay, well, let's just see what they're talking about here.
If you enlarge the pixels.
And to answer, if you're enlarging the pixels and it doesn't come out, it means that it was taken in extraordinarily low resolution in the first place. And to answer your question which you asked, Andrew, spy satellites are at a minimum of 100 miles, and they can read your newspaper.
Yeah.
So that's instant bullshit.
Well, no, because again, what this chap has failed to consider is that the satellites they put in around the moon, they put in orbit around the moon, are they're mapping satellites. They're not spy satellites. Their tasking is completely different. So they're not going to have high-definition cameras that you can take. They're not sent there to photograph the lunar landing sites. They're sent there to map the lunar surface. Again, you know, these people are absolutely bloody clueless. There's nothing to spy on the moon, is there? So you don't spend you don't spend the extra money to get a spy satellite type specification for a mapping satellite. Goodness me. Okay, next. Sticking with comments from the scientist. Let's see what he's got to say here.
Because you mentioned transmission. That's another one which I don't think anyone really thought about.
These guys certainly haven't thought of anything. If they thought about it, they don't understand it. They're just completely clueless. Okay, well let's see what he's got to say about transmission.
When you look,
This is the antenna. This is the antenna. It worked as a barbell for them to transport it out and then became the antenna.
Well, I don't know what he's suggesting here. That's certainly not the antenna they use to communicate with the Earth. That's Scott Henderson again. More gibberish from Mr. Henderson.
Right. Yeah, carry on, Colin.
well, my thing was data transmission.
Yeah.
And voice transmission. That's another one. The amount of time we were taking, the distance that you're at. I don't think anybody's really thought about that. It's not something which they really.
Yes, no one has ever thought about, you know, the transmission, the voice transmission. How long is it going to take to get from the moon to the Earth? Remember, this is our physicist here talking.
Cover, there's no delay.
Right. There's actually water here. There's actually water standing here. Water that's dried back and the mud stuck to it here with green mold around the outside.
Well, that's not going to be what it is, but that's not why I've started this clip. So I'm not going to focus on that. If they really want me to, then I'll do another video on this. But it's not. Whatever Scott Henderson says, put a line through it. It's bloody rubbish.
This one's been laying around so long it's all peeled up here and it's curled back. You can't tell me they just took it out, set it up, and took a photograph of it.
What would be the delay in communications between Moon and Earth, realistically, Colin?
You have to take into that anything, any electromagnetic wave is traveling at the speed of light, but then you've got the fact that you're quite far away, so it's going to take first of all seconds and then minutes. The further away you are, I mean, from the moon, it's probably going to take about a minute.
So the transmission from the moon is going to take about a minute, according to their physicist, their scientist. Now, when you think about it, the moon is 250,000 miles away. Radio waves travel at 186,000 miles per second. Okay, so it's going to be one way. It's going to be less than 2 seconds. It's going to be about 1.3 and a bit seconds is the delay time from the moon to the Earth, and the same is true the other way around, from the Earth to the moon. The round trip time is 2.6 something seconds. So you originate a signal on the Earth, bounce it off the moon, it returns 2.6 something seconds later, and I think I demonstrated that quite clearly in the previous video, where I showed the ham radio operator doing an EME, Earth Moon Earth echo test, and ham radio operators bounce signals off the moon routinely and talk to other radio amateurs, radio hams around the world. Radio amateurs and radio hams, of course, same thing, different terms. But I think I clearly demonstrated that. I might even find a video of them doing that at somewhere like Goonhilly, where they've got a much bigger dish, of course, a bit more transmit power, and they can. It might be a clearer demonstration of what's going on. So this is Colin, their scientist. Oh yeah, be about a minute. This is where, if he was actually on the screen, a shepherd's crook would appear, stage left, and hook him round the neck and pull him off stage. Okay, well, actually, I might see if I can find a clip of someone doing an echo test on the moon from one of the professional satellite type or deep space stations. so they get a pretty good echo off the moon, and we can listen to the delay. And Marcus Allen can get his stopwatch out. And oh, actually, no, I think Marcus Allen does give the correct. That's about the only correct thing I've ever heard Marcus Allen say. The correct delay time from Earth to the moon, and then back again. Anyway, let's see if I can find a clip that will let us see what the delay actually looks like, and sounds like. Okay, so just to demonstrate the Earth delay, here's a video. I'll leave a link to this video below. This is Moon Bouncing with Failovsky. Sort of suggests Failovsky may be famous for something. I can't say I've heard of her, but I don't think this is an English video. So she may be some sort of famous singer in Scandi Hooliland. But regardless, what she's doing here is she's bouncing a signal off the moon. She's using a bit of ham radio equipment. That is I can't remember what that is now. It's probably a Trio TS2000. And I suspect it's probably running on the 1.2 gigahertz band, this particular thing, if she's using it as a standalone unit. What the hams refer to as the 23 centimetre band. Okay, well let's just see what Faye sounds like coming back from the moon.
Of Alabama, so high, up in the sky, we lost our good old mama. I must have coffee.
She's obviously just having a bit of fun with this now, rather than trying to contact anybody. But hope you got your stopwatches out, guys, because remember it's going to be 2.6 something or other seconds for her to talk into the microphone. The signal go out through the dish antenna to the moon, come back from the moon, be demodulated, and come out of the speaker.
Or we'll die. Or we'll die. Hello, moon. Hello, moon. Yeah. This is an effort person and Peter says, are you all right? Are you all right? I'm all right. I'm all right.
There you go. She's just having a bit of fun with that, obviously, but I think that's a pretty clear demonstration of how long it takes for a signal to go from the Earth to the moon and then back again. She's talking into the microphone that's being modulated onto a transmitter. That transmitted signal's going out through an antenna to the moon. It's bouncing off the lunar surface, coming back down through the same antenna into that radio receiver, and it's being demodulated and coming out of the speaker. The round trip time is about 2.6 something seconds. Now, if you wanted to be really pedantic, you would have to add a slight delay in there for the modulation and demodulation process, but you'd be talking about microseconds or milliseconds, I would think, depending on how good the equipment is. But that certainly sounds like about 2.5 seconds to me, a bit over 2.5 seconds. So there's I think an excellent example of Earth-Moon-Earth communications with very modest equipment. That's a ham radio, piece of ham radio equipment she's using there. And I had a similar clip in the Apollo Defectives Part 1, where I had a clip there from someone using more modest equipment, bouncing a signal off the moon, and the received signal was nowhere near as good as what Faye's getting here. But the important part is the delay. The delay. Okay, so you've got to listen to the delay time, and you can also bear in mind, of course, that even with very modest equipment, you can bounce a signal off the moon. Ham radio operators do it routinely. They'll bounce signals off the moon and talk to other radio amateurs on the other side of the world that can also see the moon at the same time. Okay, next. Okay, here's Colin again, and he's going to tell us all about depleted uranium ammunition.
Well, prime example is the way that depleted uranium works on tanks. Like when it hits the outside of the tank, it will cause radiation to hit the outside of the tank, which passes radiation through the tank. And so the radiation on the outside will bounce the electrons out on the inside of the tank. So people get fried on the inside of the tank. It basically bounces.
Yeah, they use depleted uranium because it supplies radiation to the inside of the tank, and this is quite handy actually. If you've got a tank coming at you, you can fire a depleted uranium shell at them, and it will penetrate the armour. And within 10 or 15 years, everyone inside the tank will have died of cancer. They use depleted uranium ammunition because of the density of it. It's got nothing whatsoever to do with the radioactive properties of it. Because depleted uranium is something like 68% denser than lead. The Americans use depleted uranium because the Soviets come up with some really good armour, and the ammunition they had wouldn't penetrate it. They needed denser ammunition. So of course, the denser the projectile is, the more energy there is when that projectile actually hits the armour, and it punches through the armour and destroys the tank. It's got nothing whatsoever to do with radiation. Okay, next. Okay, so just a couple more clips on Colin the scientist. Right, where are we? Getting weary of this, you can probably tell.
So what was it that changed your viewpoint?
I never believed it in the first place. I don't believe anything which the government says. I don't believe anything on TV because I was just one of those children. I watched too many.
Yeah, I don't doubt that for a minute. I think this is telling us all we need to know about Colin, to be perfectly honest.
Cartoons, and the thing is that if you actually watch cartoons, they actually tell you things to your face because they're assuming that children are watching the beautiful, bright colours and they're not actually listening to what's going on. But there's a lot of information in cartoons.
So he's based his life on information he got from cartoons. So presumably Colin spends a lot of time ordering stuff from Acme rocket-propelled roller skates when he's trying to catch his Roadrunner. Or he's probably got a sea-tainer full of Acme anvils, and he stands around on the edges of cliffs. And when people he doesn't like walk past below, he drops an Acme anvil on them, presumably. Yes, he's not paranoid at all. He doesn't believe anything anybody tells him. He doesn't believe anything he's seen on television, and he's based his life on information he's gleaned from cartoons. I'll give you a tip, Colin. When Bugs Bunny sticks his finger in Elmer Fudd's shotgun, and Elmer Fudd pulls the trigger, and it goes bang, and his face is blackened, and his moustache is burnt off, and that sort of stuff. That's not gonna happen. If anyone sticks a shotgun in your face, don't stick your finger in the end of it. Talking of cartoons, I sounded a little bit like Muttley there, didn't I? Dick Dastardly's dog. All right, let's continue.
They will tell you blatantly to your face, by the way, that failed and that doesn't work, and people say, they laugh and they carry on what they're doing. Even things like Tom and Jerry, etc. There's a lot of social information with them. And so as a young child, I was already, I've always been anti-everything since I was around.
Yeah, again, this is telling us all we need to know about Colin. Lives in a world of his own. He's always been anti-everything. So he's a prime candidate for appearing on Ben's channel in a video like this.
I'm about 7 years old. It's also the fact that I came from a scientific family. So half the time my parents used to tell me that that's incorrect, and they'll show me the reason why they handed me a book. And so by the time I was 8, 9, 10, by that time I'm already telling my teachers that that's not right.
Yeah, it's not the teachers that are wrong. Sorry, it's not him that's wrong, it's the teachers. He's one of these people, in his own mind, he can't possibly be wrong. Everyone else is wrong, his teachers are wrong. So when he tells you that there's a minute delay, you know, from radio signal going from the Earth to the Moon and back, he's right, is he? Everybody else that says it's 2.3 something seconds is wrong. Is that right, Colin? Depleted uranium is used for its radioactive properties. Is it, Colin? Really? Can't possibly be wrong about that, I suppose. What else has this guy said? Oh, about the high temperature, the blowtorch, or the satellites have got to get through. Absolute nonsense. Yeah, I don't know who this guy is. Never heard of him, and he's just not worth listening to. Absolute rubbish.
And the thing is that you could Andrew can tell you, you see that a lot in my Facebook where I go, ha! I told you that 20 years ago. And people who went to school with me go, yeah, okay, Colin. The thing is,
yeah, they go, yeah, okay, Colin, because they think you're a moron. You know, you get some people, and you just want them. They're talking at you. They're not talking to you. They're talking at you, and you just want to make it stop. It's as simple as that. You go, yeah, okay, yeah, no problem. You just want them to shut up. And this guy sounds an awful lot like one of those people to me, to be perfectly honest.
that there's loads of things. People are watching them fall apart one by one. It's only recently because we're able to disseminate information so fast that people are beginning to realise what's going on. But a lot of this information is in books. I knew a lot of this information before the internet because I used to read. I used to go to a library. I used to watch things.
Yes, I'm much smarter than you and everybody else. Okay, well, let's just go to Colin's introduction and have a quick look and listen to that. Okay, now the sound is not very good on this on this original video. Now, before we get into Marcus Allen showing us all how little he knows about television broadcasting and communications links and all this sort of stuff, and he knows absolutely nothing about it whatsoever. There's a picture here. They're saying that this is a rain guard. This panel of experts here. They're saying this is a rain guard protruding on the side of the service module. And this is what it looks like on the inside. This actually looks like the inside of the capsule part of it to me, not the inside of the service module. I think this is a fudged photograph. The crew don't go into the service module, so why would you need a window? So perhaps Ben, you could ask. This is probably another one of the chef's pictures, but perhaps you could ask him for the source picture. What's the NASA picture number for this one? I'd like to see the original picture, the original photograph. I'm sure many other people would too. Okay, let's just go on to where they're going to start talking about the transmission.
Yeah. No, in fact, that's one of the major arguments against the whole idea of anything to do with landing man on the moon. They say that they did a television transmission live. For a start, there wasn't enough battery power to...
You see, Marcus Allen is speaking with authority on something he has absolutely no understanding of. I think I explained earlier in the piece, was it, or was it in part one, about the transmission power? And I looked at the NASA documents and looked at what transmitter they were using, what the power consumption would be from the batteries. This man is completely clueless.
Operate the cameras and do the transmission. And it's highly unlikely that the transmission would have reached Earth in a way that would be transmittable without some major interference.
Thank you. Unless the signal's being boosted.
Yes, and there's their resident physicist jumping on board there. Yes, unless the signal's been boosted. Good heavens, what a concept, eh? Of course it wasn't. It's a direct link, microwave link from the moon to the Earth.
And in the 1960s, once again, there weren't enough I mean, now you could bounce off satellite. There weren't enough satellites out there for them to be able to do that type of thing. And there's no reports of them doing that type of thing because they would have been...
because it wasn't required. You know, this guy's as clueless as Marcus Allen. Absolutely no idea.
That's one of the things they would have gone on about. Oh, how we bounced off the signal, and we repeated the signal, and it would have been one of those great scientific breakthroughs, and they would have advertised that like mad. Especially since it was the burst of the Russians, how they picked it back in off one system.
Anyone else finding this guy extremely annoying? God. Yeah, I'm beginning to feel like I want to grind this guy up into dog meat, to be perfectly honest.
They would have gone on about it, especially being America, but there's no mention of it.
Because it didn't happen, because it wasn't required, because you have no understanding of how it was done, the equipment involved. This is nonsense. I'm wasting my time here, and you're wasting your time by watching the Ben video on this. It's from start to finish. It is absolute, unadulterated rubbish.
Yeah, sure. And also the fact that the moon itself is spinning, the Earth is spinning.
Yes.
So to receive a signal from the moon with the accuracy required for a television picture, a movable antenna.
Oh dear. I mean, this really does show how little research these people have done into this subject. Okay, the moon is spinning, the Earth is spinning. Well, you ever heard the expression the dark side of the moon? That's because there's a side of the moon that's a bright side of the moon, and that's always the side of the moon that faces the Earth. So they land on the side of the moon that's facing the Earth, and that's it's going to be facing the Earth for the duration. So let's just so Marcus Allen has got absolutely no bloody idea. He's saying, yes, okay, it's going to need a steerable antenna on the Earth. Now, 2 seconds of Googling will show him the radio telescopes that were actually used. Initially, the signal was being picked up and relayed by Honeysuckle Creek in Australia, and of course Australia was at the time, he's right about the Earth spinning. At that particular time, the best position on the face of the Earth for picking up the signal from the moon was Australia, and they started taking the signal at Honeysuckle Creek, and then they shifted to Parkes, because Parkes was getting Parkes in New South Wales was getting a much better signal. I think that dish is something like 305 metres in diameter. And I think I'll show you a clip. Actually, I'll show you a picture of the Parkes radio telescope. This is actually the radio telescope that when everyone was watching the guys walking around on the moon, they were watching the signal being received at Parkes in New South Wales. So let's have a look at the Parkes radio telescope. Well, here we are. Here is the Parkes radio telescope, situated in Parkes, New South Wales. And I don't know where I got 305 metres from. It's actually 64 metres in diameter, the Parkes radio telescope. I must have inadvertently swallowed one of Marcus Allen's bullshit capsules. So, apologies for that. And here's another image of it, and you can see how big this thing is. I mean, that's a car there. Being Australia, that's going to be quite a large car, so you can see the size of the building. The size of the antenna, it's absolutely bloody huge. Now, Marcus Allen was saying, oh yeah, well, you know, you'd have to have a steerable antenna on Earth. Well, 2 seconds worth of Googling would have shown Mr. Allen exactly what large steerable antenna was used. Can't let the facts get in the way of a good story, can we? But oh, come to think of it, it's not good stories, it really is rubbish. Anyway, let's just read a little bit about it. Again, this is not from the Beano or from Nexus magazine. This stuff here is fact. Okay, so it says here that the The television signals were sent from an antenna on top of the lunar module and were received on Earth by 3 different tracking antennas simultaneously. Those receivers were the Goldstone dish in California's Mojave Desert, Honeysuckle Creek antenna near Canberra, and finally the radio telescope near Parkes, Australia. Where are we? Let's find the little arrow. After about 9 minutes of switching between the fuzzy receptions of both Goldstone and Honeysuckle Creek, NASA finally decided to go with the superior signal from Parkes. When you were watching Neil Armstrong and Buzz Aldrin walking around on the moon, the signals were coming from the Parkes radio telescope. The signal received by the Parkes radio telescope was better than the one received by Goldstone or by Honeysuckle Creek, so they went with that one. I think this dish is slightly larger in diameter, so it would have given a bit more receive gain, so better quality signal. So the signal went from the lunar module, little dish antenna on the lunar module, directly to this large steerable dish antenna on Earth. From there it was distributed to the television stations for general broadcast. And another interesting thing about this particular antenna, and that is okay, so here we have, aside from the Apollo transmissions, Parkes has been on the receiving end of several, I'm reading this through the camera viewfinder, so sorry about this, I'm not illiterate. The receiving end of several notable space missions. Among the images picked up by the giant dish are those of Voyager 2, because this radio telescope was built in 1961, remember? Well, I don't think I mentioned that, but it was built in 1961. So it's picking up among the images picked up by the giant dish are those of Voyager 2, which provided the first flyby shots of Uranus be too easy really, wouldn't it? And Neptune, as well as those of the Giotto probe, which snapped close-up photographs of Halley's Comet. So perhaps if we go back to, I can't remember his name now, Henderson, Scott Henderson is it? We could ask Scott Henderson to explain to us why we could get images from Voyager 2 from all the way out on the edge of the solar system there of Uranus and Neptune, why we can get those images, and the inverse square law doesn't prohibit those images, but would actually prohibit images from the moon. I'd love to hear that one. I suspect that Mr. Henderson actually doesn't know his planet from his elbow. All right, see what else we can find. Okay, here Marcus Allen is going to tell us about Nexus Magazine. Remember, he's a distributor for Nexus.
NexusMagazine.com. If you want to have a look at it, it's the world's top-selling alternative news magazine. I distribute it in the UK and Europe, and very proud to do so. Been doing it for 25 years now. Still not bored with it. There's even more exciting information in it. So magic mushrooms is our subject of choice in the current issue.
Yes, and you'd have to be high on magic mushrooms, I think, to find anything in Nexus Magazine believable. The only complaint I've got about Nexus Magazine is the pages are too shiny, because the only thing Nexus Magazine is good for is for poking a hole in the corner and hanging it up in the Kazi. It's arse paper. Okay. Thank God. Finally at the end of this drivel fest. So okay, all right. Well, I'm gonna end the video there. So thanks very much indeed for watching, and again, you know, if you've struggled through this video all the way to here, very well done indeed. Thanks for watching it. And perhaps I'll catch you again, and of course I look forward to responses these people might make through Ben, and I'm always up for a good laugh. Bye for now.
I'm not interested in imagining it.